I want to share a little bit about summation notation. Now, when you're adding a bunch of things together in a predictable pattern, we have a notation to make it faster. So let's imagine you're adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. I don't want to do that. Well, I don't want to write all of that. So often what we'll do is we will use the following notation. We use a capital sigma, and essentially what I say is I have an index that counts through. I often use I for index because I'm so creative. And then what I do is I say I equals 1 to 7. And it's understood in summation notation that the index counts through the integers starting there and ending there. So if I had I equals 4 to 8, okay, I, that would be 4 plus 5 plus 6 plus 7 plus 8. We could calculate out what that is, but the important thing is what the notation means, okay? Now you don't just have to have an I here, but this symbol means the index counts from 4 to 8. So here's another example. Let's imagine another thing to count is with k's. Let's imagine we counted from 0 to 4, k squared. This says start with k at 0, 0 squared plus, and this counts through the integers, 1 squared plus 2 squared plus 3 squared. Where do we stop? When the k gets to 4, plus 4 squared. Make sense? You could also have some sort of function. Let's imagine that you knew f of x equaled the sine of pi x. Well, then it would be totally fair to say r, the sum, r equal negative 2 to 2 of f of r. So what's that mean? It means f of negative 2, again we start here, then count by integers, not with regard to the function, but with regard to the counter. So f of negative 1 plus f of 0 plus f of 1 plus f of 2. And since sine is symmetric, I think I've made this so the whole thing equals 0. So much fun. Okay, so that's just a little bit about summation notation. When we're using rectangles, okay, you can think about both pieces of the rectangle. Pieces don't have to change. Let's imagine I'm summing up a bunch of rectangles that have, I don't know, a height that is changing. Let's imagine that the width is 0.5 and the heights go something like this height is 2, this height is 3, 4, 5. Okay, so you can sort of see what I'm getting at hopefully here. This is 2 times 0.5 plus 3 times 0.5 plus 4 times 0.5 plus 5 times 0.5. Okay, so in summation notation, I might say I equals 2 to 5 of I times 0.5 equals this. And so each rectangle has this. Also, one of the helpful things about this example is that 0.5, because it's a constant in each term, we can actually factor it out of the sum and keep the value exactly the same. So this would be describing the exact same value.